Here we see the wild Dean in his natural habitat, the AP Calculus classroom. We see him now working diligently on his AP Calculus homework. Watch as he works hard in order to earn college credit. This is absolutely brilliant. Oh, it seems he's approaching a more challenging problem. Will he be able to solve it? It seems that he will. Magnificent. And it's hard to believe that a mere 4 years ago, he was a freshman. Oh, no, continue as if I wasn't here. Just pretend I'm not here. Absolutely magnificent.
As I was saying, not more than 4 years ago, Dean was a freshman in Algebra 1, with high hopes for academic achievement. Having missed being placed in the advanced math group by 2 points on the placement test, Dean was determined. He knew that senior year he would take calculus.
Dean wasn't always the calculus genius that he is today. In fact, in his freshman year, he found himself sitting in an Algebra 1 classroom. Although wild, Dean is quite intelligent, capable of understanding abstract concepts like basic algebra. Let's approach him and see what exactly it is that he's doing. Hello, wild Dean. Would you like to tell us exactly what it is that you are doing?
Sure, I guess. I'm factoring currently.
Oh, let's take a look, shall we? Impressive. Now, is there anything you'd like to say to the people watching in your calc class today?
Calc class? I'm an way.
Oh no, he's getting on to us! Hey, come back!
And in that Algebra 1 class, Dean would learn the wonders of things like factoring, inverse graphs, exponential graphs, and much more that would lay the groundwork for the basics of calculus.
Sophomore year was an interesting one for Dean. He found himself taking both geometry and algebra 2 in the same year. Geometry helped to lay the foundations required to prove many mathematical theorems used in calculus, like IVT, EVT, and MVT. Not only did geometry help Dean with math, it also helped him in an activity some would call geometry in motion. Algebra 2 taught Dean everything else he needed to know as far as algebra can go. Currently he's solving logarithms, base 10 and base e, and many other types of problems. Let's see what his teacher, Mr. Jaster, has to say.
Oh, Mr. Jaster, I have to ask, is it true that Algebra 2 consists of maths such as factoring perfect squares, equation systems, logarithms, and other types of graphs consisting of, but not limited to, trig graphs such as sine and cosine?
Well, very naturally. Algebra 2 is all about all those things, and we do a whole bunch with graphs.
Oh, that's interesting. I also have to wonder, the general idea on logarithms is that they are some of the most difficult math problems to compute. Do you agree with this opinion?
Not really, not really. I think that in general, logarithms are easy to understand if you understand exponential functions. They are just the inverse of exponentials. If you understand one, it fits right with the other one.
All right. And my final question is, did you ever see Dean as a future calculus student?
Well, quite naturally. He was a very strong student in my class, and I think it fit perfectly for him to go right into calculus.
All right. Well, thank you then.
You're welcome. Appreciate you coming in.
Yes. Have yourself a nice day.
You too.
Pre-calc proved to be a challenge for Dean, but he was up to meet that challenge. In pre-calc, Dean would have learned everything one could want to know about math as far as trigonometry and algebra are concerned. Trig formulas, basic knowledge, graphs, sequences and series, disgusting, vectors, and much more were covered. Dean also learned the introductory calculus that he would need, such as integration and derivation. It was in this class that Dean saw the truth behind the saying, calculus is easy, algebra is hard, because frankly, the analysis of algebra is more simple than the algebra itself. It was a dark time, as he didn't know if he would make it out of pre-calc in one piece. Finally, at last, Dean had made it to calculus! The pinnacle of his high school math career, where he learned to derive and integrate, find limits, find volume using integration, and find rates of moving objects. But his calculus journey hadn't stopped there. Dean, I have a question. Might we ask how you use calculus in determining the rate laws of chemistry?
Sure. Have I seen you before?
No, of course not. I'm sure you have not. Especially not in any of your previous math classes, such as Algebra 1. No, you haven't seen me anywhere like that.
Okay, sure. So much like in calculus, how a rate determines how something is changing, so does a rate in chemistry determine how fast a reaction occurs in chemistry. So what we have in front of us is a rate law. Rate laws in chemistry can only be determined experimentally, so you have to run an experiment and determine how fast the reaction occurs, how quickly it reaches equilibrium, and how quickly it takes to run to completion. After experiment, you can then do a whole bunch of other chemistry stuff, which I honestly don't have time to explain, and then you end up getting a rate law. So rate laws can be zero order, first order, second order, which those are the three orders that you normally see them, but they can go all the way up to the nth order. But generally in chemistry, the only three orders you see are zero, first, and second. So what we have in front of us is a first order rate law. And so you can notice it already looks like you might see something in calculus like. You have negative d times the concentration of A over dt equals K, your rate constant, times the concentration of A. By rearranging much of the parts of this equation and then integrating both sides, you end up with the integral from the initial concentration of A to the concentration of A at time t of d a concentration of A over concentration of A, equaling the negative integral from 0 to t of K, the rate constant, times dt. Then integrating both sides, you end up with the natural log of the concentration of A at time t over the concentration of A initially, equaling negative K times t. And then moving that natural log over to the right side, you end up with the concentrations equaling e to the negative kt. And then once again solving for a concentration of A at time t, you get concentration of A initially times e to the kt power. So that's basically how calculus is used in finding integrated rate laws. With this integrated rate law, you can basically determine exactly what the concentration of your reactant was at any given moment during your reaction that was occurring.
BC Calculus really broadened Dean's knowledge of what calculus could do. Polar integrals, parametric derivatives, Taylor-Maclaurin series, and much more. Yeah, may have figured out who I was by the time I got to recording the BC Calculus part, but regardless, this has been his journey through calculus. However, I did manage to interview Dean about his future plans.
Hello, Dean. Oh, hello. Thank you for coming here. So, I'm a doctor working on this movie. Working for a local college, the one that you've been accepted to, UM Flint, and just have some questions for some of our incoming freshmen as well, along with you and others. Yeah. So, thank you for your time. Just recording this because it's
Okay.
easier than trying to write it all down, you know.
Yeah.
So thank you. Are you ready?
Yeah.
Okay.
Sure.
Okay. So our first question: what do you plan to do here in college?
Well, in college, I plan to major in engineering. So.
Okay, that's great. Good luck with that. It's going to take a lot of dedication. I know that. So, and I'm sure you have it. The second question is: how far do you plan to take your calculus?
Well, calculus. Well, hopefully, I earned at least a 4 on my AP Calc exam back in May this past month, and so I hope that if I earned a passing grade, that I can end up taking Calc 3 my freshman year of college, and then just take whatever level I need to get to for my engineering degree.
That's pretty wise. My final question: there's a lot of people out there who think that logarithms are the worst thing in math since dividing by zero. I've been asking people this question throughout the day, and I'm just wondering, what is your opinion on logarithms?
They're actually really easy. I don't know who would be telling you that they'd be so hard. They're literally just the inverse of e. I mean, they're not hard at all.
Oh, okay. I don't know. It's just something I've been hearing.
Okay.
Anyways, that's all I have, Dean.
Okay.
So thank you so much for your time.
Yeah, no problem.
And,
no problem.
I think we can go now.
Okay, cool. Where am I?
Oh, come with me. I'm a doctor.
Oh, okay.